Good afternoon, everyone, and welcome to today's session. As you can see on the board there, the topic that we are going to talk about or deal about today is trigonometry. So what I'm going to do is that I'm going to try and explain trigonometry from grade 10, then coming to grade 11, and then ultimately go into grade 12. So let's start. Hello. So let's begin with grade 10. Trig. So in grade 10, some of the things, or rather before anything else, we need to understand that trigonometry, similarly to algebra, I can say they are similar or rather they are the same. The only thing that differs is the fact that there are different laws that govern both. In trigonometry, we have different laws, and then also in algebra, we have also different laws governing them. Let me show you what is it that I'm talking about. The rig for trigonometry, and then algebra. Or rather, let me write algebra here. So in algebra, we know when we say x, we have 2x. And again, x multiplied by x, we have x squared. The same is true also here when we have maybe sine theta plus sine theta. We will be having 2 sine theta. And also when you have sine squared theta plus, sorry, not sine squared, sine theta multiplied, not plus, multiplied by sine of theta, we'll also have sine squared theta. So there is the similarity of trigonometry and algebra. Similarly, also when I have sine theta multiplied by cos theta, I will end up having sine theta cos theta, which can also be seen here. X multiplied by y is going to give us xy. So hence I said trigonometry and algebra similar, not the same. So they can be treated in a similar, to a certain extent, we can apply both rules, or rather same rules in algebra and trigonometry. So why am I telling you this? I'm trying to say to you, do not forget your algebra when you're dealing with trigonometric stuff. So we are going to apply the same algebra. As I normally say, algebra is the backbone of mathematics. If you do not master algebra, then basically you are going to suffer and struggle with dealing with mathematical concepts. Let's delve into this particular concept called trigonometry grade 10. I'm going to start with identities. So with identities, what is it that we have? We have two identities that we are going to talk about in grade 10. Identity number one is that sine of theta over cos of theta is equal to tan theta. And then the second identity is going to be sine squared theta plus cos squared theta is going to be 1. Someone can say I'm starting this topic in an unconventional way. It's not a transmush. We are basically going to cover everything. You will see as we get to the point. Nonetheless, in mathematics, there are proofs for everything. You have to prove that something exists in order for us to say it is a mathematical concept. For example, even here, we can prove this reality. How can we do that? We need to know something in trigonometry that sine of theta, if we use maybe a right angle triangle like this, we will be having maybe opposite. We'll call this opposite of this theta angle. I'm going to write beta, and then I'm going to write 90 degrees the angle then. So such that this triangle makes, or rather is called a right angle triangle. So I want to show you something. I'm going to use two colors now. Put in black, and then this is the angle theta. So the side that is opposite to theta, it is this side. So we're going to call this one opposite to theta. So meaning I think theta should use this color such that we will know what side is opposite to theta, and then again the side that is adjacent meaning underneath to theta, it is this one, so we'll be saying adjacent. And then we have another angle there besides theta and 90 degrees, which is beta. So this side is, the one that is adjacent to theta, it is opposite to beta. So I'm going to write opposite to beta. To theta, it is adjacent to beta. So we need to basically get to know these particular concepts, or rather how to label our right angle triangle. And then as you can see, how do you see your hypotenuse? You will be taking this line. See the tip of a 90-degree angle, you're going forward here. There, that line that meets the tip of a 90 degrees angle is going to be called hypotenuse. So anywhere, whether they place this particular shape like this is what you need to pay attention to. How do you see your hypotenuse? You just take the tip and then you go down. Where it meets that line, that is your hypotenuse. And if they've placed your theta here, that side there, that is your opposite to this theta. Like I am funded, the opposite side of me is just right in front of me. And then the adjacent will be the one underneath. If maybe they placed a beta here, we'll be saying that side that is opposite to beta is going to be your opposite, and then the one underneath it is going to be your adjacent. And I hope this makes sense. Now, let's proceed to prove the first identity. So in algebra, rather in trigonometry, we are saying sine of theta is equal to opposite over hypotenuse, and then cos of theta is called adjacent all over hypotenuse, and then tangent theta is called opposite over adjacent. So we want to prove that when I divide sine by cos, I will end up having this particular thing called tan theta. How are we going to do that? We are going to take these two things and then divide them such that we can get this particular thing. And then if we get this thing, we know it is represented, or rather it represents, this ratio represents tan theta. Now let's use that. Let's work. So we'll be saying sine theta is opposite over hypotenuse divided by adjacent all over hypotenuse. If you remember well, when I started, I said you need to remember your algebra very well when you're dealing with mathematical concepts. Let's bring back your mind. Let's go to algebra. When I have 2 over 3 divided by 4 over 7 as an example, what you need to do, we cannot do this particular thing. We call this particular question a multiplicative inverse question, whereby I'm going to have 2 all over 3, and then I change the sign of division to multiplication, and then swap the second fraction to 7 over 4, and then I multiply numerator by numerator, denominator by denominator. And then our final answer is going to be 2 multiplied by 7, which is going to be 14, 3 multiplied by 4, which is going to be 12. And then we can proceed by saying 2 goes how many times into 7? Sorry, into 2, it goes 7 times. 2 goes how many times into 12? It goes 6 times. So this is our final answer after simplifying. However, the most important thing comes here. When you change this sign and then invert this particular fraction. The same ideology we are using here. Remember, where did we get that? Algebra. Now we are applying it where? In trigonometry. Now we will keep opposite and hypotenuse because it is our first fraction. And then we change the sign and then we invert. We will be having hypotenuse all over adjacent. So now, the ones that are similar, I'm going to use the same color for them. So now I'm going to say here, such that you can see. opposite. As remember when I arrived here, I said numerator by numerator, I'm going to say opposite multiply by hypotenuse all over hypotenuse. Let me use a different color here such that we can see hypotenuse because they are the same thing, and then we have hypotenuse such that we can end up cancelling at the ultimate end. So what is it that you see? We have hypotenuse on the top, or rather in the numerator, and also we have hypotenuse in the denominator. So we can therefore cancel the hypotenuses, and then we end up having opposite over adjacent. So it will be opposite over adjacent. And then remember, what does this particular ratio gives us, or rather, what does it represent? We come back here on top. It represents opposite it represents tangent of theta. So we have managed to prove this first identity by simply using what? Algebra in trigonometry. And I hope it makes perfect sense such that we can know some of the things, or rather, I prefer to know where things come from rather than just guessing, or rather taking them at face value to say, that's a mathematics is like that. So basically knowing where they come from, it gives you that particular confidence when you're solving mathematical concepts. So that is the first one. I hope it makes sense. Let's proceed. Let's check the second identity. It says sine squared theta plus cos squared theta is equal to 1. So how do we prove this? First things first, let's check. We said sine theta is what? Let's come here first. Let's say we have this particular triangle, and then sorry about my bad drawing. If you can check here, if you remember your Cartesian plane, or rather, I can draw this here on the Cartesian plane. It's not a transmesh. This is on the x-axis, so I'm going to call this particular part, or rather side, x, and this one, since well it is parallel to the y-axis, I'm going to call y. Normally we put r here as a way of showing maybe it's a radius, part of the radius of the circle. So let's put our theta here. And then I'm going to say, what is my sine theta in this case? It's going to be the opposite over hypotenuse. All right. So it's going to be y over r. And then what is my cos of theta? It's going to be adjacent over hypotenuse, which is going to be x over r. Now let's check. Let's square the two things. So by squaring them, I'm going to have y over r squared. And then I'm going to add them. I just want to prove that it is equal to 1. X over r squared. And then I will end up having y squared all over r squared plus x squared all over r squared. Back to algebra again. Now what do we see here? We have common denominator, which is r squared. So I'm going to end up having r squared. And then on top, I'm going to add the numerators. I have y squared plus x squared. Let's remind ourselves of something. There is what we call commutative law in mathematics. Commutative law. It applies for addition and multiplications only. So for addition and then multiplication. So 2 plus 3 is the same as 3 plus 2 because this is 5, this is 5. Similarly here, 2 multiplied by 3 is the same as 3 multiplied by 2 because this is 6. That is 6. Sharp. So now let's come here. We see y squared plus x squared. So I can start with x squared plus y squared. Let me rewrite it here. I'm going to have x squared plus y squared all over r squared. Now let's check something here. Let's utilize the very same triangle, the very same triangle to use that we used to come up with this, and then find, or rather use the theorem of Pythagoras. According to the theorem of Pythagoras, we're going to add x squared plus y squared is going to give us r squared. All right. So this particular thing x squared plus y squared, it represents r squared. We can therefore conclude that r squared all over r squared, and then again we realize this is going to cancel that, and then we'll end up with 1. We have managed to prove our second identity. Isn't it nice to know where things come from? It's extremely beautiful. Beautiful, beautiful. Now let's proceed. You haven't got into the mathematics yet, but I think, or rather, the stuff of calculations or anything, but I like to believe that by knowing the background, you'll be able to solve these particular things. And then it makes me enjoy life, knowing that someone knows something. Now, we will be given a question like, let me remind you also, let's come to algebra. If I give you 2x plus 6 is equal to maybe, let's say, 12, and I say to you, solve for x, you will be saying 2x plus 6 minus 6 is going to be equal to 12 minus 6. What law did I apply? Additive inverses. So because I have a plus 6 here, I'm going to have a minus 6 here. What you do on the left, you also do on the right hand side. The sixes are going to cancel each other. I'll be ending up with left with 2x on the left hand side. Here on the right hand side, I have 6. And then here, I'm going to apply what multiplicative inverse, because I'm going to divide both sides by 2. Let me remove this. Why? Because it is the coefficient of x. So I'm going to have 6 all over 2, and then x is going to give me what? 3. So now I've managed to solve for x. Why am I showing you this? I'm going to show you how this algebraic methods are applying also in trigonometry. However, the laws are changing, as I stated in the beginning, that we can use the same algebra but different laws. Let's check what laws are changing. Let me say I have 2, where in the space of x, I'm saying sine of theta. So now we are no longer just working with values, we are working with angles. This is an angle, so we are basically trying to find the angle. So what is it that we can do? So I'm going to say maybe plus, let me say 30 degrees, or rather, yeah, not 30 degrees, but it's fine. Let me just say plus, it's fine, 6 is still fine, 6, and then I can therefore equate it to 12 as it is, and then I'm going to solve. I'm going to do that again, but I'm not gonna transpose. I'll end up having 2 sine of theta is going to be equal to 6, and then I'm going to divide both sides. I'm going to say sine theta is going to be equal to 3. Then from here, I'm applying laws of trigonometry now. I'm going to find the inverse, or rather, I'm going to say theta. I'm going to leave theta. Remember, I want theta. Similarly to here, I wanted x, not 2x. So I'm going to say sine inverse of the 3 that I found that side. Here, what is it that I've done? I divided here. I find the sine inverse. If this is going to be possible, let's check. It says math error. Why? Because this is the value that I did from the head. Now let's find something that can be given. Let me just say sine of 1. Yes, let's say here we had what? We had if I say 10, I'm going to end up having 4. So I'm going to say 10, and then here I'll end up having 4. And then when I divide 4 by 4, still gonna refuse. Yeah, when I divide it, let me put 4 here then. You see, things of doing things from the head, they end up creating this particular thing, and then we end up having a 1. And then from there, we'll have sine inverse of 1, which is going to give us a 90 degrees angle. That's what we get when we do trigonometric equations. You see, trigonometric equations, you see the similarity, same algebra, different laws. And I hope it makes sense. So that's the first part that I wanted us to do. And then, yeah, let's proceed. You can also be given something like this. Rather, let me just show you this. Let me do this. We need to remember our geometry now in trigonometry. So we have what you call equilateral triangle. What is an equilateral triangle? It's a triangle that has the same angles and same, or rather equal angles and equal sides. So I'm going to put equilateral triangle as a 2 here, 2 here, 2 there. And then the internal angles, I'm going to write them as 60 degrees, 60 degrees, and 60 degrees. So, and then what I'm going to do is this. I'm going to cut this triangle into 2 equal parts. I'm going to have here, and then I have a 90-degree angle. It's going to be, this line is going to be perpendicular to the line that is in the at the bottom. And then I'm having 2 triangles, which is the first one. They are exactly identical. 60 divided by 2 is going to give me 30 here. And then I'll be having 60 degrees and 30 degrees, and then here I'll be at 90. And then I'll be having the same triangle that side, 60. But since all is the same, let me not waste space. So now, 2 divided by 2, I'm going to have 1, and then I have a 2 there. So I need to find this. Since all this is a right angle triangle, I can use theorem of Pythagoras to find this particular side on the side. So if you can see, it is y. So I can say r squared equal to x squared plus y squared. What is my r? Is going to give me 2 squared. My x is going to give me 1 squared plus y squared. Here I'm going to have 4 and then 1 plus y squared. 4 minus 1 is going to give me 3 equal to y squared. And then here I can find the square root of both. Therefore, y is going to be the square root of 3. So I can say equal to the square root of 3. And then let me just erase that and write root 3. Someone can ask me a question, what is it that I've done here? I've shown you how to generate what you call special angles, special angles, and then where are you going to use them when you solve basically trigonometric equations? So special angles, why are they called special angles? Because you will be getting the values that are there rigid as they are, they are special in that sense. This is the first part of special angles. I'll do the second part and then the third part. So what is the trick of special angles? The trick is this. The question will be saying to you, without the use of a calculator, find the values of this. Maybe they'll be saying sine of 30 degrees multiplied by sine of 60 degrees plus cos of 60 degrees. And then what is it that you have to do? Remember, sine theta is equal to opposite over hypotenuse. So this is 30. The opposite of 30 is 1. Hypotenuse is 2. We have multiply sine 60. The opposite of 60 is root 3. And then we have hypotenuse, which is 2. And then we have plus. Cos 60, we have adjacent all over hypotenuse, which is 1 all over 2. Now let's check. For the first part, we are multiplying numerators and numerator. We're going to have root 3. In the denominator, we have 4. And then we have plus 1 over 2. We can add the two fractions by saying common denominator is going to be 4 here. And then I'll end up having root 3 plus 2 goes how many times here into 2 times. And then I have 1. I'll have root 3 plus 2 all over 4. I've managed to solve that particular equation. And then And that's basically the whole idea behind you, or rather being asked to solve questions using special angles without the use of a calculator, because they are special in this sense. There is no need for you to utilize a calculator. You can use your beautiful gray method. Now, let's do the second special angle. So these triangles will not be provided to you during exam. So the reason why I showed you how to be, I don't like to use derive, but to derive them, or rather, yeah, generate them is for you to be able to, when you get into the exam, you just draw a equilateral triangle 60, 60, 60, and then have a line drawn in between to cut it into triangles, and then you can find these values. It's easy and possible. Now let's check the second triangle. So this second triangle, I'm going to use the very same triangle, but now different values. Let me just say this, start it from scratch also. So I'm going to use what I call an isosceles triangle. What is an isosceles triangle? A triangle in which if I have 45 here and then 45 here, and then I have a 90 degrees, some of those angles in that triangle are equal to one another, right? So if maybe this is the right angle triangle in simple terms. If maybe I have A2 here and then A2 there, so I'll have to find the hypotenuse, right? And then if I find the hypotenuse, I'll end up having 2 squared plus 2 squared equal to r squared. And this is going to be 4 plus 4, which is equals to r squared. And this is going to be root 8, which is wrong. Which is wrong, 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 wrong. Let's do this. Let's have a 2 also there. When I cut this particular thing here, I'm going to have a 1 and a 1. And then I'm going to have 45, and then I'm going to have 45, and then I'll be having 90 degrees. And then since, well, this is 45 and 45 is something like this. So I'm going to have 1 and 1. Why? Because I have 45 here. I have 45 here. Mind not these values. So I'm going to look for my hypotenuse since, well, this is a 90 degrees. So as you can see, it's going to be 1 squared plus 1 squared equal to r squared. And then 2 is going to be r squared. Square root of 2 is going to be r. So basically, I'm going to have what? Square root of 2. This pen is leaving me sharp. So I have this particular thing. Now again, this is a special angle. What is it that they're going to ask you? Maybe sine of 45 multiplied by tan of 45 plus cos 60 multiplied by sine 45. So above that, there is no enough space. Now let's find sine 45. Both of these angles are 45, so we can use whichever one. So I'm going to say 1 over square root of 2 multiply tangent is opposite over adjacent, remember. So it's going to be opposite over adjacent, which is 1 over 1 plus cos 60. So now we're going back to this particular triangle, the one that we've done before. So I'm going to draw it down here. And then I have my 60, my 30, and then there, remember we have root 3, we have 2, and then we had 1. So what is cos 60 is 1 all over 2. So I'm going to have 1 over 2 multiply. Sine 45 already done it here is going to be 1 all over root 2. So 1 multiplied by 1 is 1. Root 2 multiplied by 1 is the same as root 2 plus 1 multiplied by 1 is 1. Root 2 multiplied by square root of 2. 2 multiplied by square root of 2 is going to give us 2 root 2. And then again here, I'm going to take 2 root 2 as my common denominator. 2 root 2. And then here I'll be left is 2 multiplied by 1 plus here 1. What is it that I'm going to have? 2 plus 1 all over to root 2. And then in the numerator, I will end up having what? 3 all over 2 root 2. Well, you can leave it there. You can leave it here. It's not a transmit. However, mathematically, and I think your calculator is the one that is going to give you a different answer from this. An answer that has underwent where you basically did what we call rationalization of the denominator, whereby what is it called? This is the answer that you need to get without the use of a calculator. But where are we going to catch you? Your calculator is going to do this for you. I'm going to use a different color to show what is it the calculator is going to do such that we can catch you. It's going to multiply by 2 root 2 all over 2 root 2. Ne? So remember, this is 1. We're going to say 3 multiplied by 2 root 2 is going to give us 6 root 2 all over. We'll have 4 multiplied by root 2 multiplied by root 2. And it's going to give us a 2. So we'll end up having 6 root 2 all over 8, which is going to give us 3 root 2 all over 4. Let's check if the answers are the same. 3 root 2 and then 3 all over 2 root 2. Yes, they are the same. So this is what your calculator is going to give you. But what is it that we want is this the particular answer here. If you have got this, we will know that you used your calculator, and this will be marked wrong if the status or rather the statement said without the use of a calculator, and then you will be saying, they won't know. How will they know? We will know, of course, because you are going to write this and not that. So I hope it makes sense. If this is sensible or rather it makes sense, we might as well just proceed. Why are we proceeding? I like to use this particular triangle. They don't normally say it's a special angle triangle, but I like to use it because for me, these angles are also special. And to a lot of people, this particular triangle that I'm going to write does not make sense. So I'm going to have a 90 degrees, a 90 degrees, and a 0. This y does not make sense. How can you have a 0 that is opened like that? It's not a trans match. What is it that we need to remember? Or rather, no, you should know that tangent of 90, it is undefined. So if I have 1 here, and then I have a 0, then I have a 1 there. You see? What is it that I'm going to get? Let's check if this triangle, where is it going to help us? I just said tangent of 90 degrees is undefined. So we'll be saying opposite over adjacent, 1 all over 0. So in normal mathematics of high school under caps, you do not divide by 0. So this is regarded as your undefined. When you draw a graph, or other trigonometric graphs like this maybe, you will see that there are vertical lines like that. Maybe this is where the 90 degrees is. So you'll see that maybe the graph will be like this, right? And then you'll see that there at the vertical lines, it has what we call an asymptote. What is an asymptote? An asymptote is a line that the graph approaches, but it never touches. So this is basically what we understand about why I love to use this thing, because it shows you exactly why we say tan 90 is undefined, because you can see from the illustration here that why we say it's undefined, because we are dividing by 0. So it makes sense, and I hope it does to you. So those are the parts that I wanted to talk about in grade 10. Now let's check grade 11. So what is it that we have in grade 11? So this is something, rather even in grade 10, but let me say this. When I say sine theta is equals to opposite over hypotenuse, we have the opposite of sine theta, which is cosecant theta, which is basically 1 over sine of theta. And remember, we will be saying 1 divided by opposite over hypotenuse, which is basically 1 multiplied by hypotenuse over opposite. Therefore, we can conclude that cosec theta is equal to hypotenuse all over opposite. You see? So what is it that we've done? When we find cosec theta, we are inverting the ratio. So what is cos theta not equal to? Cosec theta, it is not equal to what's this, sine to the power of 1 theta. They are not the same. They are not the same, honestly. So this cosec theta, it is just equal to 1 all over sine theta. I know, hence I said in the beginning of this video that we will be using similar things to algebra in trigonometry. So in algebra, we know when I say x to the power of -1, I can write it as 1 over x. But here, sine to the power of theta, it is not the same as 1 over sine theta. So we need to basically clarify this particular misconception that many people can fall trap into. So you do not get to do this particular thing in trigonometry. Let's check others. So that is for cosec. I'm going to write it here. Cosec theta. Like I said, we are inverting hype over opposite. We are doing the same for all. So cos, we said theta, we said is adjacent over hypotenuse. The opposite of cos is going to be secant theta, which is going to be hypotenuse all over adjacent. And then we have tangent theta, which is going to be opposite as we have seen it over adjacent. And therefore cotangent theta is going to give us what? Adjacent all over opposite. So that's the whole idea. So these are the things that we need to be aware of. So when you're solving, maybe you're given a triangle like this, and maybe you said this is 80 degrees. Let me use exactly. And then we know this is 2, this is 1, this is root 3. And then we are asked to find cosec 60, and then we are asked to find sec 30, and then we are asked to find tan 60, cot 60. So what is it that we need to pay attention to? We have to check here that what is cosecant is hypotenuse over opposite. What is hypotenuse? Which is this. So we are talking about cosecant 60. 60 is here. Hypotenuse is this one. All right. What is the opposite of that? Is going to be that. So we'll be having 2 all over root 3. This is the answer that we need without the use of a calculator. With your calculator, you're going to get something else. You're going to get 2 root 3 all over 3. Okay. So let's check secant. Secant is hypotenuse over opposite. So we said sec 60. So we are going to have 2 all over root 3 again because it's hypotenuse all over adjacent. So it's going to be 2 all over root 3. Cotangent, what is that? Adjacent over opposite. What is our adjacent of 60? It's going to be 1. And then opposite is going to give us what? Root over 1 over root 3. So these are the only answers that you need to get without the use of a calculator, because the moment you utilize a calculator, you're going to get different answers from the ones that I've written there. So I think it should make sense to say to you, you have to apply or rather comply with the rules that are being given to you. So I hope this one makes also perfect sense. And by the way, you can apply all these things that I'm telling you, in any question being given to you. Why? Because they are there to help you. So yeah, let's check something. Trigonometry. These are the same thing that we are going to talk about, right? Sure. So we have what you call identities. As I said, identities. We will be asked to prove identities in grade 11. So what identities are we talking about? Let me just check a question such that we can prove it perfectly and fast. Beautiful question, but I'm going to take it from grade 12 question print, or rather from grade 12 textbook. This one of grade 12. I might as well just mix it. Grade 11 and 12, it's fine. In grade 12, let me just mix this thing and write something here. Grade 12, we have sine 2x. X can be a theta or something, so it has to be 2 sine x cos x 4 sine a plus b. And then here I'm going to have 5 sine a minus b. Here I'm going to have 6 cos a plus b. 7 cos a minus b. Different color. So we will be having sine a cos b plus sine b cos a. What is it that you've realized? The sine had a on the first part and then cos had b. So when we change, sine will have b and then cos will have a. The same is true here. We'll be having sine a cos b. So there's a sign here which is minus, so we'll keep the minus and write sine b cos of a. So the difference comes here. In cos, when you have a positive here, when you come in between, you will end up having a minus. So it's going to be cos a cos b minus sine a sine b. One would say cos is a bit selfish because it likes following after each other. However, sine accommodated it. So as you can see also here we have a minus, so that simply means in the outside we'll have a positive. So it's going to be cos a cos b plus sine a sine b. We are not ending here, so we also have something like 8 cos 2 theta has 3 things. The first one is going to be cos squared theta minus sine squared theta, and then we will be having, this is 1, I'm going to call this one coming here 2, 2 cos squared theta minus 1. The last one is going to be 1 minus 2 sine squared theta. So this is basically the whole idea. We are adding some flash. Don't be scared, grade 11, or rather grade 12s and also grade 10s as well. You'll be able to know these things from the heart, even yourselves. So now let's check that question from grade 11, or rather the May, June, the one that was written this year. May, June, DBE, paper 2, mathematics. Sharp. What is it that we find? It said prove the identity. We have sine 2x all over 2 cos squared x plus sine x all over, it's a bit juicy underneath here. We have tan x into 1 plus cos, something that I forgot to do. But I'll do it as we go. We learn as we go, 1 all over cos x. So as we are still here, let me just show you some few things that are called co-functions. Just before we solve that. So co-functions are what? When I say cos of 90 degrees minus theta, all right, we go back to our trigonometry. So we'll be having here, as you can see, this is 90 degrees, this is 180 degrees, and then we have 270 degrees. So we have 0 degrees, sorry about that, and 360 degrees. There's no enough space. And then between here, I'm going to have the 90 minus whatever theta that I'm going to get. So the angle that I'm going to get in this side is going to give me an acute angle. So in the side, I'm going to have a 90 degrees plus theta. So it should be an obtuse angle, or rather I can say 180 degrees minus theta. Also in here, I'm going to have a reflex angle, which is 180 degrees plus theta. In this, someone would like to say 270 degrees minus theta, but we don't normally use this one. So please take it not into consideration. So in here, we'll have 360 degrees minus theta. Can proceed to say 360 degrees plus theta when we do an overall thing, but let's not take into consideration also. So now let's talk about co-functions now. What are co-functions? What quadrant is this? This is here. So it's in the first, second, third, and then fourth. So this is the first quadrant. How is cos in the first quadrant is positive. However, we are going to write its counterpart. So it's going to be sine theta. So meaning cos of 90 minus theta changes to sine. Similarly, when I say sine of 90 degrees minus theta is going to be first quadrant. How is sine in that quadrant is positive. So we'll end up having what? A cos of theta, right? And then we'll have cos of 90 degrees plus theta. Let's check. What quadrant is this? Is 2. How is cos in the second quadrant is minus. So it's going to be minus sine theta. And then we come here, sine of theta is going to be, sorry, not sine theta, sine of 90 degrees minus theta. We will check again. What is, sorry, not minus, a plus. What quadrant is this? 2. How is sine in the second quadrant? Positive. So I'll write what? Positive cos of theta. So this is basically the 4 co-functions that we are going to talk about. Someone can ask me, Franz, can't we use a co-function of 180 minus theta? The answer is no. We are using co-functions when we use 90 minus and 90 plus. So I hope this makes sense. Now let's try to solve the questions that come, or rather the question on the board, using every single detail that we know of trigonometry. Every single one of them. Yeah. Let's eat. Eat. Let's check. What do we see here? Sine 2 theta, right? What do we see here? So I have to write it as 2 sine x cos x. And then 2 cos theta. Remember when I started, I said, if I say sine theta multiplied by sine theta is going to give me sine squared theta. So that simply means even here, they combined, or rather they multiplied 2 causes. So I'll end up having 2 cos x cos x and then plus. And then on top here, I'm going to write it as like that, sine x. So basically, I'm solving left-hand side. You have to show that you are solving left-hand side to make it be equal to the right-hand side. And then what is it that we see here? We see sine, tangent, right? But we know that we have proved prior that tan theta is the same as sine x all over cos x. Please excuse me by using thetas because it's the same thing. It's not a transformation. Inside I have 1 plus. Right now I've just shown you that this is a co-function. So it's going to give us what? Sine x sharp. Now let's check. I can remove 2 and 2, cos and cos. So I'll be left with what? Sine x all over cos x. In here, sorry, plus. I have sine x. Underneath here, I'm going to distribute my sine over cos, which is going to be sine x over cos x. And then I'll end up having what? Sine multiplied by sine is going to be sine squared x all over cos of x. So now, let me use this pen. I love using different colors because it ignites my mind, or rather my brain. So let me find a common denominator here already. I've already found it, which is what? Cos theta. So I'm going to have cos theta as my common denominator, cos x. And then on top there, I'm going to have sine x, all right, plus sine squared x. Remember that algebraic thing that I've done when I said 1 over something divided by 1 over something. I have it here. It is just going to be like this. Sine x over 1 divided by sine x plus sine squared x all over cos x. So I can leave this one as it is over 1 multiplied by cos x all over sine x plus sine squared x. So I'm going to multiply both sides. I'll end up having sine x cos x. I've done this when we started. So we'll end up having on the denominator sine x plus sine squared x. Isn't it nice? So I'm going to write this here. What is it that I'm going to get? I'll end up having sine x over cos x plus sine x cos x all over sine x plus sine squared x. So here in the denominator I can take out my common factor, which is sine. So I'll end up having sine x all over cos x plus sine x cos x. In the denominator I have sine x into 1 plus sine x. So this sign can cancel that sign. So let me erase this part. In order for me to get enough space, enough space. And then I'll write everything on this side to get sine x over cos x plus. I'm left with what there? Cos x. Underneath, what is it that I'm left with? 1 plus sine x. Now, I can also find common denominator here, which is going to be cos x into 1 plus sine x. And then here, what is it that I'm going to get? I'm going to have, let me give it air to breathe. Air to breathe. I'm moving it down. So it's cos x 1 plus sine x. So here, I have cos x here. So I'm going to have this multiplied by that. I'll have sine x into 1 plus sine x plus. Here I have that. I'm going to have this multiplied by that, which is going to be cos x into cos x. Now, let's check. So I'll have what? Sine x multiplied by 1 is sine x plus. Sine multiplied by sine is going to give me sine squared x plus. Cos multiplied by cos is going to give me what? Cos squared x. And then underneath, I have cos x into 1 plus sine, sorry, not sine squared, 1 plus sine x. And then what is it that we are left with? I'm using a different color. Let's check this particular thing here. We proved this thing is equal to 1. So I can write it as sine of x plus 1 all over cos x. Someone should see what is happening already now. Sine x. And then remember when I spoke about commutative law. So I can rewrite it as 1 plus sine x all over cos x into 1 plus sine x, and this is going to cancel the 1 underneath, and then I'll have 1 all over cos x. So this is the question that we just found here, and then you can therefore conclude that therefore left hand side is equal to the right hand side. So yeah, that's what we were asked to prove, and then it is beautiful, like beautiful. The only thing that we needed to remember are the things that I've just told you to do. As you can see, this is basically algebra. We are just adding, we are minusing, we are multiplying, we are doing all this particular stuff, and it's beautiful, like magnificent. So I'd like to halt this question, or rather this particular session for today here on this particular question, and then if there's any question, please hesitate not to ask any question there in the comment section and tell me what is it that you want me to deal with. I'll proceed with this particular series of also doing trigonometry, and then many other topics are coming. Thank you very much and enjoy your day.